Okay, good morning everybody. I'd like to start off with this. Here you have two lines, the blue line and the red line. I would like you to predict where these two lines will cross. Describe the crossing point with the person next to you. I'll give you about 10 seconds. There it is, right there. And how could we describe this point? Yeah, we could use an ordered pair to describe it. What's the ordered pair? Yeah, 5, 2. 5, 2, right? Let's look at another one. So once again, let's predict where these two lines will cross. Let's say more, I don't know, maybe a little bit more of a mathematical way of going about it based on what we've just done the last unit. If we put these points on the blue line, notice that we can get slope. Notice this line goes up 1 into the right 2. Well, we know the crossing point on these two lines is going to be, somewhere over here, right? So let's just duplicate those points. Let's do the same thing for the red line. And there's our intersection point. And that intersection point's at -4, 2. Now let's do something else. Take a look at the blue line and let's get the equation for that line. Notice the pattern. The slope here was 1/2. Notice the y-intercept right there at 4. So 1/2 x plus 4. How about the red line? It's going down as it goes to the right. It's going down 2 to the right 1. Y-intercept down there at -6. Okay, let's focus just on that information there. We group all this stuff up here. Here's what this -4, 2 can do with both of those two equations there. Notice what I'm going to do here is I'm going to substitute the -4 in there for x. So I'll flip back and forth here so you can see it again. -4 is x, so let's replace those x's with the -4. Let's do the math on that. In the blue, half of -4 would be -2. Right? Go back over here to the red. -2 times -4, 2 negatives make a positive, 8. So simplifying this, the blue, -2 plus 4, that would give us +2. And 8 minus 6 also gives us +2. The same 2 that we had here with that intersection point, right? This doesn't happen all the time. This is actually a pretty special spot here. If I just picked any random point with the same two equations, say 6, 1, this doesn't work. If I put a 6 in there, take half of 6, I get 3. 3 plus 4 is 7. Back over here, if I take -2, multiply it by 6, I get -12. -12 minus 6, that gives me -18. These two numbers don't match that number here. So what's important here? What's important here is that this point right here at the intersection point, this ordered pair here will actually work for both equations here. And so that's what we're going to be up to here, at least in this lesson. Pretty simple stuff in this lesson. We're just going to try and verify whether a point is a solution to what we're going to call these right here is a linear system. And we're going to see if these points actually satisfy both of those equations at the same time. So here is your note sheet, and let's look at a couple of examples. Okay, so on these problems here, what I'm asking you guys to do is I'm giving you a proposed point, 2, 4, and you have a system of equations there. And what I'm asking you is, will that point solve that system, or will it be the solution? And so how we check to see if it's the solution is we take the x and the y coordinate there, and we'll substitute those in there for the x and the y. So if we do that for the top equation, let's see what we have. So what we're trying to do is let's figure out if we put a 2 in there for x and if we put a 4 in there for y, do we get -6? So if we do 2 times 4, that gives us an 8, right? So we have 2 minus 8, and 2 minus 8, I do believe, is -6. Alright, so far so good. We're only halfway there though. We have to check that it works in the second equation too. So what do we think here? Is 2 times 2 plus 4 going to give us 8? Yep, it does. So what that means is that 2, 4 is a solution to that system. If we take a look down here, you're seeing a situation where it didn't work. If we have 3 and 2 for this system here, notice it worked for the top equation, but it didn't work for the bottom equation. We end up getting over here, we end up getting 36, which was not the same as 24. So it's not a solution. Okay, so now it's your turn. If we were looking at these two, I'm going to give you teacher, if you wouldn't mind just pausing the video here and get you close to the computer there. Go ahead and click the pause button. Give them probably less than 2 minutes, 2 or 3 minutes here, and work on that, and resume the video after they've had time to work on those. Okay, so I've had a little bit of time to work, I hope. How'd you do? Were you able to figure these things out? Of course, you could do these things by hand and just write out the numbers and do the math in your head. Also, calculators can work out quite easily here too. Let me show you how that kind of goes. So what you could do here is, if you're looking at just the top here, great looking rectangle there, and plugging in a 4 and a 3. If we were to do that over here, we can just type in, use parentheses, and now we have 4 for the x, and then plus 2, y is 3, hit enter, get 10. Now, let's do it here. So now we have 3, use parentheses for the x value that we're plugging in here, which was 4. Close that parenthesis, and then minus, and then our y value was 3. Enter. We get 9. So we got 10, we got 9. So is this a solution? Yep. We move on to the next one. 6 times 5 minus 7 times 3. I got 9. That's 1. Do I need to check this one now? No. What we notice here, folks, is in order for us to say yes, it's got to work for both, right? And since it didn't work for the first one, why even bother checking it for the second one? So this is not a solution. Make sense? Great. So this leads us into our next little objective here on this assignment, which is leading into actually what we're going to start doing on Monday before we go on Thanksgiving break, which is solving these systems by graphing. So when we get to Monday, I'm going to have you guys be graphing these lines and then finding out where the solution is. And the solution, just linear systems, is exactly what we just saw in that little activity to start off with here. It's exactly where the two lines cross. So when we're looking at each one of these problems here and we're being asked to find the solution on this system is where those two lines cross. So if this lines cross right there, we can write our solution 2 different ways. One way I'll let you write the solution is you can write it as an ordered pair. And that ordered pair here, that's at 4, 0. Another way I'll let you write the solution is you could write it as 2 solutions here. Tell me what x equals and tell me what y equals here. Here x equals 4 and y equals 0. So I don't care which way you do it, either this way or that way. Just use one of those two. If you look at the next example, where's this solution? Right there. 2, -1 would be our solution. Moving on. Where's our solution here? Right there. Remember when we list our solution, x first, y second? I'll just do it this way this time. We'd call it 3, and then our y would be equal to what? -2. Makes sense, right? So you should be able to roll through these here.